Does anybody have 1 million ants?
We've got a real exterminator who's been by.
We can pay exterminator?
Huh?
We can pay exterminator?
We have one on call and they're paying him because apparently, I sent the picture to Miss Beverly who showed it to Miss Curry and they were a little freaked out by the amount of ants that were over there.
The million ants?
There's a lot of ants over there.
Was it that deep?
Yeah. I mean, I'm not that freaked out by it, but I blew it up quite a bit, so they were a little freaked out in the picture. I think Miss Beverly's still up there scratching. All right. So, I think we did fission and fusion. Did we talk about what they were last week? I think we did it in one class. We did that before we left?
Yeah.
Okay. But we did not talk about their advantages and disadvantages, right?
I knew that dog.
Yeah, you too much right. So, we talked about fission and fusion last week. Somebody tell me what fusion was. Alright, so fusion was to combine into one large nucleus. Alright, what was fission?
When they defuse into like two.
Split. I like that. They defuse and they split.
It's a large nucleus split.
Okay. So we're going to split into two smaller nucleus.
Yeah.
Alright, or nuclei. So, we want to talk about their advantages and disadvantages. What you do? I don't even want to know, do I?
It's not a bad. I threw a goldfish in his mouth and I actually made it.
Yeah, it was pretty bad.
I saw a smile on her face when it happened. Genuinely happy.
Buckets.
You can't hit a trash can, and she hit his jaws.
Yeah.
Now, did we talk about what fission was used for?
No, yeah.
All right, so what two things did I give y'all that fission is used for?
Power plant.
Power plants and bombs, nuclear weapons. All right, so what are the advantages of fission?
You can make bombs.
All right, we can. That would be a disadvantage that I'm going to use it for. All right, so what's an advantage of fission? What do we use the power plant for? All right, so an advantage of fission is it's controllable. So we can use it for power plants and energy. Okay, fission is controllable. We can harness the energy from a nuclear reaction and we can create power plants and we can sell the energy, power cities, counties, large areas and regions. Now, the downside to that is what? What does fission create? Waste. Okay? So the downside to fission is fission creates nuclear waste. It must be stored. Now, that's going to lead us into our final topic, which is half-life and how it goes away and gets off the earth. And in a lot of cases, its half-life is so large, for all practical purposes, it's never going away. Okay?
So it's never going to go away for the half.
Because let's say the half-life is 5 million years, and half of it will decay in 5 million years. Well, half of it will be gone in 5 million years. So in 5 million years, you'll be dead, your children will be dead, grandchildren, your great-grandchildren. I mean, in 5 million years, for all practical purposes, the Earth may be gone in 5 million years. Dinosaurs may be re-roaming the Earth. We don't know what's going to happen in that length of time.
The best thing to do is just kill all people that are there.
Like, what we put nuclear
Like,
waste?
I honestly would do that. Like, I don't care. I would say
I mean, at the moment, we largely store it in tubs or put it in cinder blocks, and we just store it in various facilities around the world. I mean, we have storage facilities here in the States. The problem is what happens to them over time. They break down and they leak. Yes. And you have to be careful that it doesn't get into the ground or the groundwater. Even when you think about Chernobyl and the meltdown that it had back in the 90s, some of it went up into the air. And of course, if you remember your earth science, it gets into the wind and into the jet stream, and that travels globally, right? So we could even test here, and some of our cows ate grass that had nuclear radiation in it and got into the milk, and we could test that. I mean, it was a very minute amount, but we were able to track that even here in the United States, and it happened in Russia. Okay? So it's a huge issue. Okay? And that area of the country in Russia, I think Benjamin tells me it's in Ukraine, will never be able to be inhabited again. Okay?
Gotta rock it, just like one-way trip into the sun.
Okay? Speaking of the sun, all right, what process takes place on the sun? Does anybody remember
Solar,
from our time studying energy forms?
nuclear.
It's nuclear fusion. Okay? So, if fusion takes place on the sun, can we control fusion?
No.
No. Okay? So a disadvantage is nuclear fusion.
I have a question about half-life.
All right, hang on.
We have problems.
All right, so fusion is not controllable. The temperatures are like the sun. All right, because if you remember from back when we studied energy, all right, can you what? Yes. All right, the temperatures are like the sun because the sun is an example of nuclear fusion. All right, the sun, the stars were the two examples that we talked about. They were nuclear fusion. Now, if you think about the temperatures on the sun, now you've never been there, but you've heard about it your whole life.
I've been there.
The sun.
I've been there.
Okay. Could we support a reaction that is anything like the sun here on the earth?
No.
No. Okay? So we can't use nuclear fusion here on the earth. Now, the thing that would make it nice if we could is fusion has no waste. Okay? Nuclear fusion has no waste, which would be fabulous. We would love to be able to use nuclear fusion here. But the problem is temperatures are so high, it would melt everything that we were trying to use it for. Okay? We can create nuclear fusion on the planet. The problem is the way we create it is a nuclear bomb. So it's going to destroy everything that we're trying to do. Okay?
Maybe we can take it to the moon and try it.
I don't think the moon's going to survive.
Well, we could take it to another planet and try it until it works, and when we find out a way to work it, dude, y'all, we haven't even got to Mars yet. Dude, so
Maybe one day that will be
maybe
doable.
one day. I'm not saying it right now. I'm just saying, like, y'all gotta think about it. You gotta think about this. Y'all
Maybe one day.
I'm gonna die.
And it's possible that one day it will work. We're just not there yet.
Okay, so like, if it's 5 million years, right, and half of it's gone,
Don't go there.
does that mean that half is gonna be a quarter in 5 million years?
That's what we're getting ready to talk about.
For real?
Yes, that's what we're getting ready to talk about.
If they take place on the sun.
Yeah, nuclear fusion takes place on the sun. That's an example of fusion. So are the stars.
So how do we know what it does if we can't even see it?
What?
Fusion.
There are scientists much brighter than me who've said that's where it takes place. That's what it is. How they know,
What about black holes?
that is well past what I know.
Dude, black
You
holes.
can
dude,
read up on that.
dude, I feel like it's Thanos trying to come here, but he can't.
We're gonna watch that.
Feels like you can read up on black holes. It does not interest me, so I have no knowledge of it.
Black holes, like, they don't suck anything up. They just shred
Let's
them.
get black holes.
All right, everybody caught up?
Like towards July, like you straight up.
You know, like,
I'm not waiting on you to check
it
the
doesn't
phone.
get bigger. It doesn't.
All right, so what is half-life?
It's basically
This is the last topic we have, and we're done. Okay? Now, the only thing that we have left is, like I told y'all, acids and bases. And I typically teach that as part of the review, but I can throw it in right here at the end with the pH scale, because we just need to talk about pH. And most of y'all are going to be like, oh yeah, I remember that, Ms. Wall. We can do that. Okay? So I'll throw it in at the end. All right, so radioactive half-life. Radioactive half-life is essentially, how do I want to word this? When 1/2 of a sample decays. Okay? So, let's say, just to illustrate, that we have 100 grams, and I'm just going to call it compound X. And we're going to have a half-life of 5 years. All right? Just to illustrate how this works, because I don't want to make it complex and hard to follow. So, tell me what you remember about the law of conservation.
How could you forget? We learn it about literally every subject.
Okay, so matter is not created or destroyed. So if we start with 100 grams, how much do we have to finish with? 100 grams. Okay, everybody clear on that? 100 grams. So half of the sample is going to decay. So, what's it going to decay into?
Air.
All right, half will be radioactive when it's done. And I ran out of space there. And half will be stable. Okay, that's what I want you to get out of this. So after the half-life goes by, half of it will be radioactive and half of it will be stable. All right, so I'm just going to sort of draw pictures here to illustrate how this works, and then we'll talk about the calculation. All right, and I'm not going to teach it with Math 3 exponential functions. We're going to draw a picture. I assume Math 3 is like a bad memory, and so, or it's a
Stupid.
So we're going to do it with a table. It's much easier. All right. Okay, we're not going to worry about you cheating. All right. So if we start with 100 grams, okay, after 5 years goes by, all right, after 5 years, first of all, how much am I going to have left? How much has to be left? Still got to have 100 total left, right? But according to what we've said, half of it will become stable.
That's what I meant.
Okay, I know you did. I was just checking to make sure everybody was with me and I still had 100. So, 50 of it undergoes decay and becomes stable.
Wait.
But the other 50 grams is now still going to be what, though? Still going to be deadly, still going to be radioactive.
So was it radioactive before, or is it?
All of it is radioactive before. All right, so let me write radioactive over here. So the initial 100 grams is some kind of radioactive goo that is nuclear waste of some kind. Okay? Not all nuclear waste has terrible half-lives. Some of it could be seconds, some of it could be minutes, some of it could be millions of years. Just sort of depends. Okay? So I picked one that's got one that's 5 years. All right? Now, after 5 years, 100 grams is now 50 grams it's radioactive, 50 grams of it is stable. Now, another 5 years goes by. What happens? After 5 more years goes by, what happens to our radioactive goo? All right, Jose says it's gone.
It's all stable.
All right, I hear another. It's all stable.
It goes back how it was.
No. No, it's still 100. The 100's not going away.
That's what I was saying.
Dude, it turns into 25 and then other 25.
All right, so this 50 grams that is radioactive does what?
Half-life again.
Okay, it divides again. Okay, so that 50 divides, and so I wind up with 25 grams is radioactive, and now 75 grams is stable.
Dude, I'm actually smart. I came up with that earlier and I'm not even a scientist. And we didn't even learn it yet.
Okay? So, this 25 grams that's now radioactive is going to do what?
Half-life again.
It's going to do it again.
And so it's going to be like 12.3 or stuff.
Thank you. Thought I was in 4th period for a second.
Let me get some water. Can I get some water?
Yeah, let's get some water.
Thank you.
All right. So if it divides again, you have 12.5 that's radioactive and 87.5. Now, if this keeps happening, will the radioactive stuff ever go away? There will always be a trace amount. It will get smaller and smaller over time. Now, think about it. If you're that really bad plutonium or uranium that has a half-life of 5 million years, is that stuff ever going away?
Yeah, in 5 million years. Yeah, probably. No.
For all practical purposes in our lifetime, our children's lifetime, our grandchildren's, great-grandchildren's lifetime, is it going away? You're talking a cycle of, let's just say, a capacity of 400 years, assuming they all live to be 100. Is it likely that that stuff's going away? No. That's why people pick it and want nuclear weapons done away with, and they want nuclear power plants done away with, and want alternative uses of energy instead of nuclear. Okay? This stuff does not go away. Now, let's talk about how to calculate. All right, write that down, and we'll talk about how to do the problem without using your math 3 skills. Okay? No weird exponential solving the logs or e's. I'm going to teach you how to solve using a chart.
That's why I got a present for you.
Is it the present I'm going to want?
Probably.
Really?
Yeah.
Can't wait to see this. I don't chew gum.
I just got it out the box.
Does anybody want gum? I don't chew gum.
I'll eat it.
I do.
Oh, please. Give it back to me.
You could give it to one of those people who said they wanted gum.
What?
Yeah, I was gonna say what?
You want this gum?
Sure.
I appreciate it. I just don't chew gum. My teeth don't line up after I chew gum.
What does it mean?
I know it's odd, but.
Dude.
All right, we caught up?
No.
It's only 3 lines, people. Come on.
I'm done.
I don't know.
That's a good question.
I would say I support you. I would say I support you.
Yeah, I know. It's really that bad.
I agree.
Ouch.
right, we got it written now?
No.
All right, so the T-chart we're gonna make is gonna say amount and time. And it doesn't matter which one you put on which side. So if you get it backwards when you're working it, it's irrelevant which is on which side. Okay? Now, when you fill it in, the time is always 0 to start. All right? Because no time has ticked off the clock initially. Okay? You're trying to figure out what's left. All right? In the calendar, you're going to add the half-life. No time is ticked off. Here,
So it's like,
you're going to put your given amount. So you got to read the problem to figure out what they gave you. So, to do this, you're going to add the half-life. Now, you have to find the half-life. It's going to be given to you in the question. It's not going to be the same for every problem. So you have to figure out what that half-life is. Okay? Everybody with me on that? Arkell, pay attention. Stop watching on your phone.
stop watching Naruto, dude.
We turned him into Mickey Mouse again. All right? And over here, what did we do to the amount every time over here in our sample? What do we do every time to our amounts? We halved it. Okay? So over here, every time, we're going to divide by what?
2.
Divide by 2 because we need to find half of it, half life. Everybody with me on that? So, now all we have to do is gather the pieces out of the word problem and we're good to go. So, what is our given amount given in the question? How much of the radioactive goo did they give me in the question?
50 grams.
Okay, so in the question, it says 50 grams of radioactive goo. Everybody okay with that?
Yeah.
So we're going to put 50 grams here. All right, what did they say my half-life is?
25 days.
Okay, 25 days. Everybody okay with that?
Yeah.
So we're going to add 25 days. All right. So after 25 days, how much of that 50 grams is left?
25.
Now, if they wanted to know how much was left after 25 days, I'm done with the question.
Right, but they don't.
Did they want to know how much was left after 25 days?
No.
Nope. How much do they want to know?
100 days.
They want to know after 100 days. So can I stop?
No.
No, I got to keep going in the chart because they want to know after 100 days, right?
Yeah.
So add another 25 days. So add the half-life. The half-life was what?
25.
25 days.
What is half 25?
So 25 plus 25 is 50 days. All right, what do I do here? Divided by 2. So 25 divided by 2 is 12.5. You got a calculator. You can get one. Okay? Did they want to know how much was left after 50 days? What does it ask for in the word problem? If y'all would stop playing with your phones, you'd be surprised at how much easier it is to catch on. Yeah. They want to know after how long? 100 days. All right, so what am I going to do here? Add another 25 and we have 75 days. So what am I going to do here? Divide by 2 and I get,
You said we weren't going to have to go to math class for this.
you're dividing by 2. You got a calculator.
Dude, it's a debt. 0.5.
There's a calculator. All right. What am I going to do here? Add another 25, which is 100 days. And then what am I going to do here? 3.125 grams.
Oh, snap. You're popping on.
Okay, and that's the answer. All I did was add the half-life
Wait a minute. Yeah, no.
and then divide by 2 on the other side. You with me?
Bro, it's cold in here, dude.
It's not cold in here.
It is cold in here. I drank like 3 bottles of water. Leave me alone.
Okay.
You don't ever do you get cold after you drink a lot of water?
Not that I can recall.
Okay, drink a lot of water and then wait till you get cold. You're gonna get cold.
Okay. I'll try that tonight.
That's right.
All right, you have a sample, so let's just fill this one in. You're out. Put your phone up. Try paying attention. All right, so if we look at amount and time. All right, what does time always have to start at? Time always has to start at 0.
Yeah, correct.
Okay? I told you, I already have a sample, so let's just fill
Will
it in.
there be any questions where it's like it says the half-life is 100, but it's been 25 days already or something like that?
It could be. I don't know. I never get to see the test. All right, so what is my given amount in the question, Ureli?
It says, you talking about the 1/2
Oh,
or the?
I just thought it. At least you said it.
I did not mean to.
I don't know.
Stop playing your phone and play with Mario and pay attention.
I wasn't even on my phone.
What's my amount, Isela?
2.
10 grams. Okay, see how it says 10 grams right here? That tells us our amount. You with me? All right, what's my half-life? Now, Jaya? 45. Okay, so the half-life is 45 seconds. All right, everybody with us? All right, so the half-life we add on this side, we divide by 2 over here. So we're going to add 45. 5 grams. Now, if they wanted 45 seconds, I'd be done. Did they want to know 45 seconds?
No.
Nope. They want to know what's left after 225. So I got to keep going a little bit. Add 45, and I get 90 seconds. That's going to be 2.5 grams.
Is there another example like this?
Huh?
Is there another example like this? Can I do it on the board? I want to try something.
Okay. So I told you there's more than one way to work this. You've learned a way in math class. I'm just not teaching it that way. So 1.25 grams. All right. Add 45 again. You get 180. 180. What's 120? Is that 0.6? 125?
This is 0.75, right?
Yeah.
0.675? Try to do it in my head.
It's 0.625.
25. All right. And then 180 plus 45 will be 225. All right. And then that'll be 0.3 something. Do that one for me.
0.31.
0.31?
Yeah.
Okay. And that will be what we want. Everybody got it? Yes. You think you can do it on your own?
Yeah.
All right. You do what you want on your paper and see if it works.
I'm going to try it up here.
No.
I don't have any paper.
There's paper right here on my desk. Get paper.
That's what she wants.
Oh my God.
I want everybody to be able to try it, and then we'll see if your way works too.
All right.
All right, everybody got it? All right, try that one. See if you can get the right answer. There's a colored pencil over there. You need a pencil that you can bubble in with, though, because you're going to take a practice test here in a moment.
I got one for that.
40, just like the state test. It's a release version.
What?
We're going to try it. Yes, you have to, considering I'm going to grade it.
You're gonna grade it?
How would you say that?
With my phone.
If I get 100 on this.
You get a grade on grade or something?
Huh?
You gonna be grade?
Well, that's the part that we were talking about a while ago. Were you not listening to that either?
I mean, I was.
All right.
Paper.
I forgot what you said.
So, happening.
I'm gonna do it now.
Smart way. That's smart way. This is which way. I guess it's the
We just type it out and figure it out like okay, so this is.
You got it?
Yeah.
Yeah, I think that.
Was that yes for everybody since, you know, you yelled the Diavian answer for everybody?
I'm not ready.
Is it 5.46? Let's go, dude. It works.
This?
That doesn't work.
What did you do?
Look.
I told you, there's lots of different ways to work these.
If the last one is 48, 48 divided by 86. So that means that the very last one is going to be 6. So all you have to do is 350 divided by 2.
All right, we're ready to do it?
You basically did it the same way, but like shortcut.
You know, it's actually like this way the time doesn't even happen. Figured it
So
out.
you want to that the same amount of time you have to divide.
So you can just do it really quickly instead of having to write all that stuff out. I'm pretty sure there's an effective way to do it. You know, yeah.
Diavian, I'm supposed to remind you of the SAT on Saturday.
I know.
Okay.
Saturday.
I'm trying to figure out, I know one. I cannot figure out the initials on this other one.
She says Tuesday.
No. I'll see him probably this afternoon. To remind him. All right, so. All right, so the amount is what?
So the amount?
Yep.
Yeah.
All right, and time always starts at?
0.
Okay, what am I adding?
8.
All right, so 8, what's 350 divided by 2? 175. Is that what they wanted to know?
No.
Nope. So add another 8, we have 16. What's here?
87.5.
Okay, does that one know 16? No. 24.
No.
43.75.
You said 43.75? I don't know, that's why I'm asking you. Okay, 32. What do you get here?
21.87.
All right, 40, and you'll have what?
10.93.
I meant 42. Sorry.
Here?
Yeah.
All right, and then 48, and you get what?
5.46875.
Okay, that was good.
We get somewhere in that range? 5.4?
Yeah.
All right, everybody good with it?
We have to get things.
You need grams, but remember the test is multiple choice, so the units will be there.
I'm just saying.
Okay? All right, last thing we're gonna do real quick. All right? Victory. All right. pH. And I think most of you know this, but we'll just run through it real quick. 0 to 14. Where's neutral?
7.
Okay? All right. This is usually where people have forgotten, if they've forgotten anything. Where's the acid range at? Where's the base range? Okay. 0 to 7 is the acid. All right. This is the part that we need to make sure you know. All right. If they talk to you anything about colors, all right, litmus paper, hydron paper, pH paper, yes. All right. Acids are red. Okay. If they talk to you about colors, acids are red. All right. If they talk to you about bases,
Blue.
that's right.
Is that why water's blue?
No. Bases are blue. All right. Now, if they talk to you about an ion, I don't know if they will, but if they do, bases have OH or hydroxide. Acids have hydrogen. If you know that, you can answer any question on acids or bases on the test.
All right, man.
It's that simple. That's all I need to tell you about acids and bases, and you can answer virtually any question there is on acids and bases. Okay? Hydrogen or H is an acid. Acids are red between 0 and 7. 7 is neutral. Hydroxide or OH is a base. Base is an NaOH. So if you see something on the test and it says NaOH, is that an acid or a base? What'd you say, Elizabeth? Why'd you say it was a base? Because it has OH, okay? Sometimes people will try to tell me that's an acid because it has hydrogen. It's not. It has an OH that's together, so that makes it a base. As long as you can identify that, you got it. If you see HCl, what's that? Okay? Starts with an H. That's an acid. That's a base. Telling them apart is that simple. If it's got OH together, it's a base. If it's got H at the front, it's an acid. You don't have to know anything more complex than that. And you just mastered acids and bases without me teaching a thing.
What'd you say?
I said, if it starts with an H, it's got an H on it or a hydrogen, it's an acid. If it's got an OH, it's a base. You don't have to know anything more complex than that. Okay? That's it. And you've mastered acids and bases. You already know pH and colors, so I don't need to teach that. All right. Bubble sheets. Now, you get your periodic table and you get your formula sheet. If you don't have one, I recommend you borrow one.
How
We
long
got a
is it?
formula sheet.
40 questions, just like the state test. That way we can grade it and see how you would do if this was the state test.
Malik, let me get
There, your relative.
Why can't they not get 100 when they grade?
What do we need to erase?
That's what we were talking about a while ago. I have decided how I'm going to count it. We'll see how y'all do. And then we'll make a decision after that.
Like, does it have to be like black or is it just that way I can erase?
You can do it in pen or pencil. It doesn't matter. You're both graded either way.
I tried.
That's why I was talking.
As well as this pink will grade it.
Huh?
This pink will grade it.
Pink? I don't know. I know it will grade red, blue, and black. I don't know what will grade pink. All right.
Give us one that don't hit us on the head. What? I said don't hit us one on the head.
No fun.
I told him it wasn't easy for her at all. Straight easy.
Can I give you yours?
Thank you. Yeah. I told you.
No phones. Put it up.
Now it's time to get away.
I want you to focus on this for a while.
No.
I'm not telling you gotta take an hour and a half to do the thing, but I want you to try to focus on all the questions.
Can I pass that?
Come here.
Only got pens.
Everybody have their charts. Pull them out. All right, use your charts, read the questions. If you don't know, guess. You know, on the test booklet, put a question mark. So you know you didn't know how to do that one. And when we're walking through it, I will talk about it and explain how to get the answer.
Right, Angel.
Yeah. Yeah, I want you to bubble them in. I'm gonna grade it.
So you can use,
Yes, use both charts. Say what? Yeah, you can use them. My phone will grade it. I know it'll grade black, blue, and red. I don't know if it will grade pink or something like that. I'd rather not find out today. All right, everybody got one? There's 40 questions. Works just like the state test. Say what? Oh, should I give you one?
I gave it to Isaiah.
Isaiah, you got an extra in there? Eduardo, you got an extra?
Sorry. Where's the paper? Like, when should we?
Come there on my desk. I need more. I'll get some out. There, do the practice test. Try. You might surprise yourself with how much you know. Not you. Him. Although, take your butts out. Okay. Yeah. Other one too.
Yeah.
Give it back to me again. free here. We're just working on makeup time. Hold on, has to be. I promise. Sure. Big best. You want something to drink? Yeah, we need some more. There's some more. Nigel, go check.
Okay, Adriana. You know,
Can you get some water?
Yep. All right, if you guys will, since it doesn't appear most of y'all are done, make 2 stacks on my desk and we'll finish it tomorrow. Make 2 stacks. Huh? Make sure your name's on the test. You get it back.
I haven't seen him yet.
I was
Nate?
Oh, you want another name?
Chavez.
Yeah, Samir, Avian, or A.B. Cruz Chavez.
It's A-M, is it A-M
I-R.
I-A-R? No, I-R, I mean,
Yeah, A.B. Cruz Chavez.
Name?
Nah, his girlfriend wanted Amir, and then he liked A.B. Bye guys, see you tomorrow.
Alright.